Well, here we are about 2 weeks later with the next installment of our scratch building series. And first video has racked up about 4,000 views already. A little bit surprising for me, considering I only have a little over 2,000 subscribers. So either people are taking second and third looks at this video, or there's a bunch of new people that have joined. Either way, welcome. This is an interesting development. I'd like to take a moment here to pick up on some comments that came through on this first video, particularly about the fact that I had plans to work from. I just would like to reassure folks that there are ways to get measurements for buildings without having the actual plans, and one of those ways is using our friend Google Maps. So here is an aerial view of the site. In Google Maps, there's, well, first of all, there's a light version of Google Maps and a full version. So if you take a look in the right-hand corner of the screen, you'll see there's a lightning bolt right here. If you click on that, it toggles between light mode and full mode. So make sure you're in full mode. But once you are in full mode, you can, by right-clicking anywhere on the image, so let's take the top left corner of the building, we'll right click that, and you'll see you get a selection of different things that you can do. Right down at the bottom is this thing that says measure distance. So we click on that, and then we click on another location that you want to measure the distance. So let's look at the top right corner of the building, and there you have it. You see we have a measurement here of roughly 355 feet. It also gives you the total here in this box. There you are. So very easy to take measurements from Google Maps in feet or metric. You can toggle between metric or imperial just by clicking on the ruler on the right here. And that just toggles back and forth. So anytime you want to have a sense of length or width of a building, or railway cars even if you want, you can see you can measure the length of these railway cars here. Measure distance there, and just drag it. And there you are, 67-foot flat car. See? Easy enough. Now, as far as vertical dimensions are concerned, we can go to our friend Google Earth, and up here on Google Earth we have a set of tabs, and we click on this one. This is the one that says show ruler. We click on that, and there's our ruler. And the neat thing about this is we can select 3D path here, and it will simply allow you to click on any 2 points, and it'll tell you the height. There's opening of the door, right? Roughly 19 feet. See that yellow line? It tells you the dimension right there. You can change, again, whether it's feet or centimeters or yards or miles, depending on how big your dimension is, but we'll leave it on feet. So if we want, let's see, back of the building, get the full height of the building, there, and there. There you go, 44 feet, and if you recall from our drawings, there we are, 45 feet was what the measurement said from our plans. So really don't need the plans for the most part. Certainly if you want to know what's going on inside the building, you'd have to get inside. But there are ways to have a look at typical buildings through images on Google as well, to give you a sense of what steel warehouses are like on the inside. Type in steel warehouse buildings. You can see I've done this before. There's lots and lots of images here that come up that are useful for external views and interior under construction views, and you can click on any one of these and it blows up, and there's usually related images that you can find, give you a sense of relative dimensions of steel beams and columns a very, very useful tool. Now, notwithstanding all the things I just said about trying to do this kind of project without drawings, it certainly is beneficial to have them. And since I do have them, I'm going to take advantage of that in trying to figure out some of the sizes of the different columns and beams that are in the building. The biggest column here, if I scale it off um, by using the height here, the 45 feet as a scale, this width here works out to about 4.5 feet, and in HO scale that's about 5/8 of an inch. So what I've done here is I've laid out the actual building envelope uh, in HO scale, so that I know roughly what it looks like, how it fits on the layout before I start building it. But it also gives me an opportunity to look at, what kind of materials do I want to use. The actual columns, I mean, this is a purpose-built building, and you can see that the design is not off the shelf. These beams that are supporting the roof are not a uniform thickness. That doesn't mean that I have to design the model one exactly the same. Certainly if I was a nitpicker I would do that, but I'm not. So I'm going to try and figure out what comes closest to giving the same look and feel. And as we've seen from images on Google, there are many, many, many different ways to design and build these buildings, and many of the images we saw in fact had straight or constant width beams across here. So it really isn't necessary to have this odd shape here. So I had a look at what's available out there in the industry, and we have a couple of good suppliers here of I-beams. We've got Evergreen and we've got Plastruct. Evergreen has it's more delicate look and feel to it, and they have some smaller sizes. Plastruct can give you much larger beams. At first I was considering using only the Evergreen, and you see here this is the largest one they have. It's 3/8 of an inch. I thought maybe I would double up on these to make the wide column, since there is a notch in it to allow for the crane rail. But as I got to look at the Plastruct catalog, I found that they in fact have a 5/8 inch I-beam. So I thought, here's an ideal product for the actual main columns here, and they come in packages of 3. This particular one does. The smaller they get, the more beams you get in the package. This is a 7/16 of an inch package, and it has 5 beams in it. This one has 3, but given that they're 15 inches long each, it actually works out quite nicely because I can cut each of these into 3 equal pieces, and they match perfectly the height that I need here, 3 3/4 inches. So that's going to work out well because I need 17 columns, but 2 packages is more than enough to handle that. As far as the roof beams are concerned, again, I thought 7/16 inch is about right, and I don't mind if it's a constant thickness across. It's about the right thickness at the center of the roof, and at the same time, where there's the notch here for the crane rail, the width of the column decreases to about 7/16. So again, I can use the 7/16 of an inch width to finish up the top a third of each column. So I picked up 2 packages of the 5/8 and 3 packages of the 7/16, and I think that will do for all the columns in the main structure. I still have some of these Evergreen and narrower cross-section beams that I can use for the columns and roof structures in the pallet storage area, because that's a smaller height side building, and the beams are not anywhere near as thick as the columns and beams on the main building itself. And there also are vertical members holding up the end walls, and those again I think I can get away with using some of these narrower evergreen products. As far as the roofing materials are concerned, I think I was very fortunate to find this evergreen product. It's a 1/4 inch spacing roofing, and you see there are actual notches every 1/4 inches. That represents about 2 feet, and it comes with these tiny little strips of styrene that you glue into each of these notches, and what you get as a result is something that looks almost exactly like what we saw in the prototype roof. I think this will work out quite well. Bought a few packages of that to cover all of the roofing in the building. Finally, we have some choices to make in terms of the siding material for the walls, the exterior walls for the building. I had picked up some of this large sheet board and batten siding from Evergreen, since I was on the Evergreen website looking up potential products, and I thought this might be useful. It has a 1 foot spacing of ribs, but it lacks any detail between the ribs. Not quite sure that that's the right way to go. I started looking at other alternatives. Pike Stuff has some siding material that is very similar to the notch design we saw on not on our prototype, but on other prototype buildings. This is the Pike Stuff prefab warehouse walls and downspouts kit. Comes with 2 sheets within each package. It's something that I would use if the prototype was actually had the notches in as opposed to the notches out. As you recall from the first video, we got some comments from our viewers, and thank you, Sparky, confirmed that it was in fact notches out and not notches in it. If it had been notches in, I think this is the way I would have gone, but that's not the case. So as far as notches out, there are a couple of other choices, also from Pike Stuff. Their roofing system has the notches out, and it also has the 2 little ribs, if you call them that, between each of the main notches, and that's very similar to the Storm Seal product that I showed you in the first video. Interesting though that if you buy the roofing material in strips as opposed to in a kit, the tooling is a little different. These sheets here are what come with the some of their building kits, but if you buy this material on its own, it's got a slightly different spacing, and in fact I think it's an even closer spacing to the prototype than this one. So I'm leaning towards getting some of this Pike Stuff material for the sides. Even though they call it roofing material, it looks a lot closer, I think, to the Storm Seal, there's the side view, to the Storm Seal product, the prototype that I showed you in the first video. And if you look close up at the Evergreen product, it's just a straight board and batten, frankly, with nothing in between. So while it's the right spacing, I think it's lacking in that detail that I'd like to give it to make it look more like the prototype. So wouldn't mind having opinions and thoughts and comments from viewers, and tell me what you think. But I think I'm leaning towards this one. Well, here we are with the bits and pieces ready to make our first test fitting of how the various components of the columns and beams go together. We've cut out our first section of the 5/8 inch wide main support column, 3 and 3¾ inch long. We have the 7/16 wide I-beam for the top section of the column, and we have the roof
support beams, also 7/16 of an inch wide. Both the roof beam and the upper section of the column are cut at a slight angle to match the roof angle, as we got from the drawings, as 1 to 12, and that's simply measured 1 block up, 12 blocks over. So when the drawing was made, it matches that angle. So it's a simple matter of holding the I-beams firm while we take our handy styrene cutter and cut vertically along the lines in the graph paper to give us those correct angles. And that way the columns and beams fit snugly against one another. I've also created from some O2O styrene sheet some strips to match the width of both the 7/16 inch I-beam and the wider 5/8 inch I-beam, and that is to create these little pieces that cap the top of the I-beams like that, to make for a better fit between the change in width of the 5/8 inch to 7/16 inch, as you would find on the prototype, and also providing a proper seat for the crane rail that will sit on top of it. Similarly, the 7/16 inch wide strip is used here at the end for the two halves of the roof beams to butt up against each other nice and squarely. So now it's a matter of duplicating this 17 times because there are 17 columns for the building that we're building. So it's going to take me a while to do that, and I guess once I have that done, we'll put together another video and show you how far we've come along. Till next time.